Hey everyone, so today we're going to be talking about graphing rational functions, day one. So the first thing we want to do is just define what is a rational function. So a rational function is a fraction of two polynomials, like x squared plus 2x plus 5, x minus 7, or it could just be a constant, and q of x can't be 0 since we wouldn't want it to be undefined. So the basic rational function is 1 over x. Okay, so we're going to kind of explore what happens as we go towards infinity, negative infinity, and kind of what this graph looks like. So if you think of plugging things into 1 over x, 1 over 2, 1 over 3, 1 over 4, 1 over 5, okay, so as we go out towards the right, okay, so as we approach infinity, okay, our numbers are getting smaller and smaller. Just a friendly reminder, this e negative 4, 1e negative 4, that means 1 times 10 to the negative fourth, which would be 0.0001, okay, versus negative 1e to the fifth would be negative 1 times 10 to the fifth, so negative 100,000. A really big number. So it depends if the 5 or 4, that exponent is negative or positive. So let's take a look at this graph. So I have a graph here for us. The red is 1 over x. So as you guys can see, it kind of looks like these two big loops, okay? And, you can see this, like if you plot in 1 over 1 is 1. That's that point right there. There it is. And every other point we can see as we get towards closer and closer to the x-axis, the issue that's going to come up here is that we can't plug in 1 over 0, right? 1 over 0 would be undefined. So our numbers actually get really, really big and really, really small. And these blue and green lines, I hope you guys can see them, those dashed lines, those are asymptotes. And asymptotes are lines that we're going to approach but not cross, except for basically one special situation, which we'll talk about later. But for now, think of them as magnets, right? Our graph is magnetized but does not cross. Okay, so this is our graph. So as we get closer to 0, okay, so as we get closer to 0, look what's happening to my y values. They're going up, 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 up towards infinity. And then same from the left, as I get closer to 0, I'm going towards negative infinity. Okay, the interesting one is as you branch out, what if I go with my x's? What if I take my x's and go towards infinity? Okay, what's happening to my y values? Take a look. 0.161, as I scan out here, 0.059. They're getting really, really close to 0, okay? And same thing here, getting really, really close to 0. You're looking at the y values as x's goes toward negative infinity. Okay, so we're getting close to 0 actually in both directions, and we're never crossing that line. As we come from the left, we're going towards negative infinity. And as we come from the right, we're going towards positive infinity. Okay, and this actually makes sense. Like if we were to plug in what's 1 over x, if I plugged in 1/2, 1 over 1/2 is 2. So it's actually getting bigger. 1 over 1/10 is 10. So let's go back. Again, just kind of the general idea of what these look like is what you need. So as x goes towards positive infinity, this was when it was going this way, right? It was getting closer and closer to 0. As you can see here, 1 times 10 to the negative fourth is 0.0001. As we go towards negative infinity, that's when the graph was going this way, right? It kind of looks like this. This, and then kind of a curve that went like that. So as it went towards negative infinity, we went towards 0 as well. It got closer and closer. Okay, as I approach 0 from the left, notice what's happening. My numbers are getting really, really, really large negative, so negative infinity. Versus as I approach from the right, okay, what's happening over here, I'm going towards positive infinity. Okay, so again, those lines that we're approaching at 0 and y equals 0 and x equals 0 are called asymptotes. Okay, so if we kind of replicate this on our graph, it would be dashed lines. You could be fancy here. I just was kind of lazy, but you could actually use your notability tool. There's a dashed line, and then you could hold a nice straight line, except get it actually at 0, and then draw in those arrows. So asymptotes, again, have arrows. They are not part of the graph in a sense that they're not graphed points, but they are kind of a structure of our graph, and they're going to help us draw the rest of our graph in. So if we think about what's happening here, again, our asymptotes are equations of lines. So x equals 0 is a vertical line at 0, and y equals 0 is a horizontal line at 0, okay? And our graph, as we remember, kind of looks like this. So we were very, very close. We kind of branched away and then got very close this way. and something like that. Okay, we can't graph anything down here because then it wouldn't be a function. So you want to still make sure this is a rational function. So if I were to do the vertical line test and kind of drag this along, this should still pass the vertical line test. All right, so yeah, that's kind of the general idea. If you were to write domain and range, you could plug in every number except 0 for x's, and same with y's. It covers every single number from infinity to negative infinity except for 0. So we're not going to work with domain and range too much, but I think it's good to think about. If you take a look here, I can't plug in 0 for x, so we have to skip over it. That's the domain restriction. And also, this would never be equal to 0. 1 over x. When is that equal to 0? That would be undefined. All right, so let's dive into what all these pieces are. This page is super important. It's actually, we're not going to write that much. It's more just kind of notes for you for a lot of this chapter. So make sure you feel comfortable about what these things are. Abbreviations, we're going to use vertical asymptotes. Again, those are vertical lines, okay, like a column holding up a building. Horizontal, like the horizon, going from left to right. We'll call these VAs and HAs, so don't be surprised to see those abbreviations. Okay, as I approach a vertical asymptote, I'm either going towards infinity or I'm going towards negative infinity. And they could be the same direction too. But either way, that's a giveaway if I'm approaching infinity or negative infinity. Again, it will never cross a vertical asymptote. Think of it as a magnet. And the way you find this, important part here we're going to be using, how do you find this from an equation? Okay, there can be more than one. You set the denominator equal to 0. So when is x minus 4 equal to 0? When x is equal to 4. So that would be my vertical asymptote. So, if I were to graph this as x approaches 4 from the right, okay, we're not going to graph this right now. I just want to show you kind of what a situation could be with this kind of limit, or what's happening as I approach 4. We approach infinity. Okay, and as I approach 4 from the left, we approach negative infinity. So we'll always do this with a graph. So I'll show you when we graph it kind of how we would know what this is and how we get those values. Okay, so horizontal asymptotes are a little more difficult because we've got a couple situations. So first of all, this is when we're going towards infinity, or going towards negative infinity, excuse me. We go towards the horizontal asymptote. So again, it's kind of that magnet idea, and we're not crossing it, except for a certain situation. We'll talk about this tomorrow when there's 2 or more vertical asymptotes. So how do you find this in an equation? Important part for you guys. First of all, there's only one or none. If the degree of the denominator is bigger than the degree of the numerator, the horizontal asymptote is automatically y equals 0. If the degree of the denominator is equal to the degree of the numerator, then we take the ratio of the lead coefficients. So let me show you what I mean by that. Okay, so and by the way, if the denominator is less, we're not going to worry about that this year, so that won't be happening. So look at these. We have both first degree polynomials. That's the highest degree. So you would have y equals 3 over 1, lead coefficients. 3 over 1 is 3. So my horizontal asymptote would be at 3. This one, we have a 0th power over a first power, meaning the bottom is bigger. So I would have y equals 0 automatically. That's this first rule here. Okay, and for f of x, that's what I'm talking about for these. As I approach infinity, I would get closer and closer to 3. And as I approach negative infinity, I would also get closer to 3. I'm going towards those asymptotes as I get farther away from the center. If you're not totally understanding this approaching business, that's okay. I think it will make more sense when we graph it. Okay, the last 2 things to talk about here would be the y and x intercept. What is a y-intercept? You guys know this. It's when it crosses the y-axis. It's either once or possibly never. And we find this from setting x's to 0, and we simplify the fraction. So set x to 0. This would be 0 plus 2 over 0 minus 4. So my y-intercept is negative 1/2. So I'd write that as 0, negative 1/2. Okay, how do you find an x-intercept? There could be none, one, or many. Okay, we write it as a number comma 0 versus 0 comma a number. We set y to 0. So basically we write this, x plus 2 over x minus 4. But notice that if you were to cross multiply or something, we would always just set the numerator to 0. So I just say, typically the easiest thing is setting the numerator to 0. So when is x plus 2 equal to 0? At negative 2. So my x-intercept would be negative 2, 0. Okay. So now what we're going to do is actually try some of these. We're just going to try 2 examples, and then we'll try a couple more in class. So here's your steps. I'll kind of talk about these for when we go, but if you ever need to refer to how to do these problems, that's your little instructions. So first thing I would do is find the asymptotes and actually graph those first. Okay, and you always want to simplify. There's nothing to simplify with this fraction, but if you could factor, etc., you might want to factor first. So what's the vertical asymptote? Vertical asymptote, we set the denominator equal to 0. We write this as an equation, aka you don't just write 2, you have to write x equals 2. Okay, horizontal asymptote, how do we find that? That's when we compare the degree of the top versus the degree of the bottom. So notice degree of the top is 0, degree of the bottom is 1. So since the bottom is bigger than the top, we get y equals 0. Okay, y-intercept, you set x equal to 0. So 3 over 2 times 0 minus 4 is 3 over negative 4. So 0, negative 3/4. And your x-intercept is when you set the numerator to 0. Numerator equal to 0, that doesn't give us anything, so there's not any x-intercepts, which can happen. Okay, so let's see what's going on here. I would first plug the vertical and horizontal asymptotes. I'm going to pick a dashed line. I'm going to do red. So I'm going to do x equals 2. That's a vertical line at 2. I draw that in. I put arrows. Then I have a horizontal asymptote at 0. Yikes. Okay, fix that there. Put some arrows on it. Awesome. There's my structure. Those are lines I'm not going to cross, and I'm just going to get very, very close to it. The other thing you want to graph, if you can, is graph any x or y intercepts. So I have a y-intercept at 0, negative 3/4. We're just going to approximate. I know it's not going to be perfect. Oops, I'm still in a dashed line. And then we're just going to graph. Now, your only options is it looks like this or it looks like this. Okay, because we were given a point right here, we know it has to be in this bottom half. So we're going to go towards the asymptote, towards the asymptote. Okay, smooth curve right there. This half is done, right? Because we have something there. So now we want to go on this side. And we have to pick, not pick, but we're going to figure out, is it like this? Or is it like this? Those are the only options, guys. So what you want to figure out is you're going to take a value, such as 3. You want to look right next to the vertical asymptote. So don't plug in like 6. Plug in right next to it. So since it's at 2, I'm going to plug in 3. Okay, if I plug in 3, 3 over 2 times 3 minus 4. Okay, that gets me 3 over 6 minus 4, which is 2. That means I would plot at 3, 1.5. Now, you don't have to actually plot that point. You could just say, oh, it's positive, so I'm above the x-axis. This is totally fine with me. If you like plotting a point, go ahead. 1.5. I know I have to go through this point. Okay, and now I am done. Again, my vertical line test, if I were to do it, I should be able to scan along, never cross more than once, and I should be covering all the x values, right? But I should never have any of these like swoops, if you want to call them that. I shouldn't have them on top of each other because then it would fail the vertical line test. And that's about it, guys. The last thing here, as we approach 2 from the right, so take your right hand. If you're approaching 2, what's happening to my y values? They're getting really, really, really big, approaching infinity. What happens as I approach from the left? Negative infinity. Okay, so we're going to try one more. That's it for graphing. Again, all you need to graph are, I don't want these green lines in there. Sorry, I don't know if I'm going to be able to erase that. There we go. Okay, things you need to graph, these 4 things. Okay, for sure. And then you just need to have those pieces of graph or those curves of the graph in the right sector. So you don't really need this point. You just need to know it's above the asymptote. All right, let's try one more. And again, we're going to go through this in class, so always bring in questions if you have them. 6 minus 2x over 1 plus x. Okay, vertical asymptote. You take the denominator. You say when is x plus 1 equal to 0? That's when x is equal to -1. Horizontal asymptote, we think powers. This is a first power, this is a first power, meaning we take the ratio of the leading coefficients. So really, if we rewrote this, it would be -2x plus 6 over x plus 1. So it'd be these two numbers. -2 over 1 is -2. We just divide them. Okay. Y-intercept is when you set x to 0. 1 plus 0. 6 minus 0 over 1 plus 0 is 6 over 1. So 0, 6. And your x-intercept is when you set the numerator to 0. When is the numerator 0? When x is 3. Okay. So, pause if you need to. You've got those four things. Let's graph them first. So, again, we're going to go to a dashed line here. I've got -1. I graph it. I've got -2 is your horizontal. I graph it. Switching back to my regular pen because now I want to graph 0, 6 and 3, 0. These are the points you definitely have to plot. And I know, again, my graph is a curve and it's going towards the asymptotes. So towards the asymptotes, through the point, and it's getting really, really close to -2. Okay, so I'm already done with half of my graph. The only thing I need, guys, think about it this way. Is this graph like this? Or is it like this? Okay, so all you need to do is plug in a number right next door. So how about -2? We're going to plug in x equals -2. 6 minus 2 times -2 over 1 plus -2. That'd be 6 plus 4, so 10 over -1. So I don't need to plot -10. Okay, that would be, somewhere down here. All I know is that it lands down there, so I can draw on my graph something like that. Okay, so it doesn't have to be perfect. You don't need to graph that point. You just need to figure out it goes below the asymptote versus going above the asymptote. And again, that's it for the graph. You don't need any other special points graphed. When we approach infinity, okay, when x's approach infinity, what's happening? My graph is getting really, really close to -2. Okay, and when I approach negative infinity, I'm getting really, really close again to y equals -2. So I'm getting close to that horizontal asymptote. All right, so that's about it for those. Please bring in any questions. I know these are a little difficult and sometimes feel a little abstract as to how we graph. So we'll try the last few examples in class. And yeah, thank you again for watching.